that some ancient Romans' homes were fitted with a type of air conditioning. It's true, some Roman homes had a network of pipes built into the wall so that during the hot summer months, cold aqueduct water could be pumped through these pipes, cooling the interior temperature of the house. This was an effective early form of air conditioning, although it must be noted only the rich elite of ancient Rome could afford it.
It is just a touch after 4 p.m. on a beautiful Monday afternoon. Welcome to the program. My name is Sibusiso, and as always, I'm coming to you very excited to share all this math content that we're going to be sharing with you on the show that is proudly brought to you with lots of love by Liberty. A very special shout out always goes out to Liberty for affording us this opportunity to share all this awesome content that we're going to be sharing with you in the next hour. Remember, guys, like we always encourage you, if you haven't done so and you're looking for a wealth of resources, go to your app store. Go to your app store and look for what you call the Tenfold Education app. It's an awesome app packed with a lot of very useful resources. It will help you stream this show live. It will give you access to videos that will also build you with all the basics that you need from grade 10, 11, all the way up to grade 12. It's got maths and science as well as life sciences, so do make sure it's also sponsored by Liberty. Do make sure that you have this app I promise you will never regret having that app. In addition, guys, perhaps you are looking for resources such as past papers or maybe the questions that we are using on our program today. Just go to WhatsApp, guys. When you get there, look for Dex. You can find Dex by just texting hi. Dex is also armed with a lot of very useful videos that, not videos, but past papers and resources that you can also work with as you're preparing yourselves for the upcoming exams. You know that those exams are going to be very crucial, guys. And maybe you're one person who works better by watching what we're doing. That's why you're probably watching Tenfold live. So if you go to YouTube and look for the Mindset Learn channel. We also have a lot of very awesome videos as well, covering a lot of topics and concepts that we've done on the previous shows. And maybe you're not one person who's looking for what we're dealing with today. I promise you though, we're gonna have an awesome show. You don't wanna miss these ideas that I wanna share with you that prevent you perhaps from acing your math. So even though sometimes you might feel like there's a topic that you're good at and you understand, there's always something you can learn from any show that you're doing here on Tenfold Live, because what we are covering here is obviously the ideas that help you to understand how to work with these concepts. So if you have watched the videos that we have on YouTube and you keep watching this program as well, I promise you guys you're going to do well on your prelims as well as your finals. Speaking of which, before we even begin, go to your socials and then let your friends know that we are up and running and they're missing if they're not watching Tenfold Live. Just go to your socials, text them, let them know that we're here. They must also be part of this program, because in the next hour, I'm going to show you how do you nail data handling. How do you work with data handling, which is sometimes referred to as statistics. Remember, there are 3 types of things we can ask you in data handling. We can ask you to work with ungrouped data. We can ask you to learn how to work with grouped data. And in addition, we're going to be looking at questions that are touching on what we call bivariate data. So you don't want to miss any of that. A lot of very interesting jargon is coming up next. So without any further waste of time, let's jump right into our first question and see what this one is all about. All right. So this is question 2, and it reads as follows. It says a company recorded the number of messages sent by email over a period of 60 working days. The data is shown in the table below. Now, the number of messages between 10 and 20 was 2, right? Number of days was 2. Messages between 20 and 30, number of days was 8. Messages between 30 and 40, it was 5. 40 and 50, it was 10, all the way until the data that we have for the number of messages between 80 and 90 is also equal to 2. Right. So now what we're looking at here is a table of what we call grouped data. Right. Before we even go far, I just want to explain the following about what is going on here. Okay. So you will notice that in this table we are given that for the number of messages between 10 and 20 messages, that happened over 2 days, right? You'll see here between 20 and 10, we got a number of 2. There's like 2 in total, right? And then between 20 and 30, the number of days over which this happened is actually 8. And then between 30 and 40, the number of days that this happened is actually 5. We don't know, right, how many messages we got on which day, but we just know that between 30 and 40, the total number of days was 5 in total, where we got those number of messages. All right, cool. So let's see what the first question is asking us to do. The first question is asking us to estimate the mean number of messages sent per day, rounded off to 2 decimal places. Right. So now what's the key word here? We are asking you to work out the mean. And we all know that the formula for working out the mean is equal to the sum of all data points divided by how many they are. Now, the problem with grouped data is you don't really have the unique numbers. You don't actually have the actual values that you're working with. For example, if you go back to the table, the first row, just the first row, tells us that for 2 days, over 2 days, we got messages between 10 and 20. But do we know on which day we got how many messages? We don't really know that, right? We just know that between 10 and 20, we got between 10 and 20 messages during the time where, like over 2 days. So what you will need to do here is you're going to work out an extra column here okay, which I'm going to squeeze. I'm going to just squeeze it here because we don't really have much space if we think about it. So in fact, let me put it here on the left because we still need to use this table to try and find something else which is going to be for the drawing of what we call the cumulative frequency curve. So allow me to extend this table here on the left, right, in order to assist you to understand. How do you work out the mean if you are dealing with grouped data? So you will see here, you have to find the midpoint values, right? Between 10 and 20, the number that is between 10 and 20 is 5. So those are the midpoint for each class that you're looking at, right? Between 10 and 20, the midpoint value is 5. Between 20 and 30, the midpoint value is obviously 25. Okay, that's not 5, but it's 15. Let's fix that. Yes, it's 15. And between 20 and 30 is 25. Between 30 and 40 is obviously going to be 35. And then in the next class, the midpoint value is going to be 45 of the class. And then the next one is going to be 55. And then you're going to have 65. And then you're going to have 75. And then you're going to have 85, right? So what exactly are we doing here? This is actually very important. I want you to understand what we're doing here. We don't know the number of messages we got on the first day and the number of messages we got on the second day. We just know we got between 10 and 20 messages over 2 days. So now we're going to assume that for those 2 days, we're basically getting 15 messages on each day. Okay? So that's basically what I'm trying to do here. That's basically what I'm claiming. If you go to the second class, the class between 20 and 30, I know that in that class between 20 and 30, the number of messages we got were between 20 and 30. However, that happened over how many days? It happened over 8 days. But we don't know which messages we received on which day. So we're going to claim that on each one of those days, we got 25 messages. Very important. So now that means I can now be able to work out my values, my data values. It means that I'm going to have 15 how many times? Twice. I'm going to have 25 how many times? 8 times. I'm going to have 35 how many times? 15 times. So that's basically what you're going to do in order to try and figure out what the average is going to be here. Okay? It's going to be 2 multiplied by the midpoint value, 15. We need to add that to what? To 8 multiplied by 25. We're going to have to add that to 5 multiplied by its midpoint value, which is 35. We also need to add that to the product of 10 and 45. Okay, I'm basically multiplying, for example, 12 here. I'm going to multiply it with 55, which is the frequency value on the left there. Right. Okay, so 10 multiplied by 45, we're done with that one. And then the next one is going to be, obviously, like I said, 12. You have to multiply 12 with 55. We have to keep going. Okay, and then we have to add, the other one is going to obviously be 18 multiplied with 65. Right, and then the next one is going to be 3. Okay, there's 3 there, multiply 3 by 75. And then last but not least, we're going to take 2 and multiply it by 85. All the answer that you're going to get from this sum, we obviously have to divide it. This sum that you're going to get here, we need to divide it by how many data points you've got here. So how many data point values do we have here? Obviously, that's going to be the sum of all your frequency values here. The number of days over which this happened, we've got 2, you add that with 8, you add that with 5, you add that with 15. So the sum of all these values, which is basically the sum of the frequency values, will help you to understand what is the total value of the days over which this thing was actually happening. So let's call the calculator and try and figure out what is going to be the sum of all those values that you have over there. So we've got 2, we are adding 8 on that, and then we have to add 5 on that, and then we have to add 10 on that. Then you're going to have to add 12, and then you're adding 18, and then lastly you're going to add 3 and then add the 2. Hopefully everything is working well. I'm ending up with an answer of exactly 60. Now what is good about this is if you go back to the love letter, the opening statement, we were told that this is over 60 working days. So I'm expecting the total sum of the frequency to be indeed equal to 60. So we just have to divide this by a value of 60. Okay, so let's find out what the answer is going to be here. If you just add all those things that you have over there and then you divide it by 60, you can be able to find what the answer is going to be. All right. Now, what I'm going to do here, because this is actually going to be the same as just typing all these numbers in a calculator, manually, that's what you guys will need to do if you're trying to figure out the solution to this. Alternatively, you could have used a calculator to try and find the mean. Then how would you do that? You just go to your calculator, you're looking for the stats mode. So you go press on mode, and then you're going to select stats, which is option 1. So I'm going to select stats for option 1. And then I'm not going to select option 1 for a plus bx, but I'm going to select option 0 because I'm trying to work out the values here that you're going to have. So now the calculator gives you a table with x values and the frequency. The frequency is how many times does that particular value appear on your table. Like I said, we don't have the actual values. So we are going to use the midpoint values, okay, to try and claim that 15 is appearing twice. We are claiming that 25 is appearing 8 times. We are claiming that 35 is appearing 5 times. So that's basically what is going to happen here. If you don't know how to switch on frequency in your calculator, guys, we'll talk to you about it at some point during the show. Okay, so my x values are going to be the midpoint values. So I'm going to put 15 here. I'm going to say equal to. The next one is going to be 25 here. I'll say equal to. The next one is 35. And then we're going to have 45. And then obviously 55. And then after that, we're going to have 65. Just be careful not to make a mistake. And then we're going to have 75. And then the last one is going to be 85, right? So don't worry about them. You will notice that your calculator is giving you frequency values of 1, 1, 1, 1, 1. It's assuming that each one of the numbers that you're putting as x appears once. So what you'll need to do is go back up to the very first value. Our first value was 15. And put in the frequency values. What is the frequency values? The number of days over which something was happening, which is the second column. So 15, we're claiming that it's appearing twice. Okay, and then the next one is going to be 8. And then after that, you're going to have 5. And then after that, you're going to have 10. Okay, and then after that, you're going to have 12. And then after the 12, you'll have 18. And then after 18, you'll have 3. And then the last number, of course, that corresponds to 85 is going to be 2. Okay, you just press equal to. Now, your calculator at this point has the data you just gave it. You're going to ask it to give you the mean, right? So how do you do that? You will notice that if you want to go back to try and find the values that are calculated here, you need to go and find where the stat is. Once you get to stat, you can be able to then ask the calculator to retrieve all the stuff that you've worked with. You will notice that on this sharp calculator, on button 8, it says STAT there in, I think it's green. So I'm going to push the alpha button first, and then I'm going to push that stat button first. First of all, obviously, we have to clear the screen, okay? So you have to clear the screen. You can clear the screen by just pressing that button, and then you're going to go alphabet, and then you press that stat button there. So it's going to ask you, what are you looking for? Statistics values, are you looking for the variables, are you looking for the sum, are you looking for the minimum and the maximum? So I want to go to option, obviously, 0. So I'll press option 0. If I press option 0, it just spits out all the values that I might be interested in. First of all, the n value is 60. That tells you the total number of values you inserted. The x bar is the mean. That's what I'm looking for. Obviously, S with X, that's the standard deviation, 17.1698, blah, blah, blah. What am I interested in? I'm looking for X bar, the 51.33. That's going to be the mean value of this data. Okay, so that's how you could actually, what is it? I think it's 55.3. Let's call the calculator again to confirm that. Yes, it's 51.33. Okay, so 51.33 will be the estimated mean. Okay, cool. So I just showed you how to work this out either manually. You could insert these values here, multiply all those numbers, add them up, and then divide them by 60. You should get the same number of 51.33 as well. All right, moving right along. 2.2 says draw a cumulative frequency graph of the data on the grid provided. All right, so we have to draw the cumulative frequency curve or the cumulative frequency graph for this. Remember, for you to draw the cumulative frequency graph, you need to find the cumulative frequency values. So we're going to have to go back to the table and then extend the table by adding an extra column on the right-hand side where we are finding the cumulative frequency. Because the graph we're going to have here is going to be the cumulative frequency on the y-axis versus the number of messages that people received on the x-axis. So let's go back up and update our table. So we're going to have to update our table. I want you guys to look closely here at what we're going to do. So normally, nobody never actually tells you that you need to extend this graph and have the column, okay, for the cumulative frequency. So this is going to be the cumulative frequency column, right? How do you work out the cumulative frequency, right? So what you need to do to work out the cumulative frequency is you obviously start with the first number, right? You start with the first number. When you start with the first number, you'll see that we've got 2 in the beginning. So that 2 comes here. I'll write it first as the first value. It tells you the number of days that we've got up to so far. So for the first 2 days, we had messages between 10 and 20. And then if I consider the next day, the next group of the next class has 8 total number of days. So on 2 days, if I add 8 days, okay, I'm just adding with those ones that you have over there, I'll have 10 days. And then if I add the 5 days that we have in the next class, that's going to give me a total of 15 days. If I add those 10, I'll have 25 days. If I add those 12, I think it's going to be 37. Okay, arithmetics. All right, let's just extend this. Please don't mind my ugly looking table. And then I'm sure you can see that now we're up to 25 plus 12. If you're adding 25 and 12, you're getting 37, which when you add to 18, you're going to get a value of 55. So this is 55 people at days we have accounted for. If you consider the next 3 days, you're going to be sitting at 58 days, and the last 2 days tells you that indeed the total number of days we are actually observing this data for is 60 in total, right? Just keep that in mind. You keep adding when you're moving forward. If anybody asks you to reverse the table, you're just going to subtract to move back to try and get the values that are under the number of days. So what do we have to do? We now have to plot. Question is, what are we plotting on the cumulative frequency curve? We're going to plot the number of messages. Which ones are we looking at? We look at these ones, the 20, 30, 40. It's the upper limit values of your classes. Those will be on the x-axis. You're plotting them against what? Against the cumulative frequency values. So we're plotting them against the cumulative frequency values. So the cumulative frequency values are going to be on there. They're going to be on the y-axis. So be careful there. Make sure you're plotting the right things, the right column versus the right column. So that's the data versus the cumulative frequency. So I'm going to need you guys to have this in mind. We're going to find a point where 20 on the number of messages matches 2 on the cumulative frequency. Okay, so let's go find that. 20 matches 2. So 20 on the x-axis, we can see here. And then when you go 20 on the x-axis, I'm looking for 2. I think it's just these blocks are moving in, they're going up by 1. So I'm going to be here. This is where 20 and 2 meet each other. That's my first point. The second point that I'm looking for is where 30 corresponds with 10. It's the 30 that you've got here and the 10 that you've got on the cumulative frequency. Those values, we're going to plot them. So where does 30 match 10? Okay, 30 and 10, they meet each other exactly here. That's where 30 and 10 meet each other. Go back up. We're now looking for 40 and 15. Let's be a bit quick now. 40 and 15, they meet each other here. And then the next one that I'm looking for is going to be 50 and 25. Okay, let's go 50 and 25 is going to be here, all right? And then the next one after 50 and 25, we're looking for 60 and 37. Okay, 60 and 37, 60 and 37 is way up there. 35, 36, 37 should be here. Right. You've got a graph paper. If you have a graph paper, there's no way you could get this thing wrong. It has to be accurate. Okay, the next one is 70 and 55. 70 and 55, that's going to be here. There we go. Okay, it looks like it's one that has got the biggest jump between all of them. All right, and then after that, we are going to obviously have 80 and 58. So where's 80 and 58? 80 and 58 is going to be very close to 60. And then the last one is obviously going to be 90 and 60. So that's basically what you're ending up with as the final solution for the last point, where 90 matches 60. Okay, so when you join them, we're not going to join the dots, right? So that it looks like something that looks like this. That will be wrong. Okay, please don't do that. We are going to draw a curve. That will be a mistake. So we're going to have to try and get a best curve you can out of these points. All right, let's just see. Trying to run through them. Don't pass the 91. Just go through all of them nicely in a curve version. It's going to create something that looks like the letter S of some sort. Right, there's a cumulative frequency curve. Now, this will be incomplete because your graph has to be grounded somewhere. Now, the big question is, where do you ground it? Do you ground it at 10 or do you ground it at 0? You always go back to the table. It will tell you what is the smallest possible value that you can ground at. And in our context here, the smallest number on the table is 10 on the data here. The number of messages is between 10 and 20. So we're going to ground it at 10, not 0, grade 12. It's always the last value that you've got, the smallest possible value that you have on your table. So in our case, we are supposed to ground it at 10, so I'm just going to push it to 10 and 0. And that is a complete cumulative frequency curve for this information that we have over there. It looks like a letter S. It has to be a curve. It can't be a polygon. Be careful of that. The last question says, hence estimate the number of days on which 65 or more messages were sent. So we have to estimate, okay, looking for an estimation for the number of days on which 65 or more. 65 or more. Okay, so how do you do this? You go back to the cumulative frequency curve. You go find where 65 messages is, right? So let's look for 65 messages. 65 messages sits exactly here. Let's find it here. 65 is going to be 62, 64, 66. So 65 is somewhere here at the bottom. That's where 65 is going to be. So I have got 65 messages right there. Now, after doing that, I'm going to call a line to try and assist me to try and figure out what's going to happen here. So you move from here, you go straight to the graph, straight up, 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 up to the graph, and then you sit wherever the graph is, from 65 straight up. Now, after doing that, you then go from that graph, you read on the y-axis, what is a cumulative frequency value that corresponds to that x value, right? So I'm getting my value there to be at 49. So I'm getting a 49 there. Of course, it's an estimate. It's not going to be exactly to the point. If you've got 49, you're fine. If you've got 50, you're also fine. If you've got 48, it will also be accepted. So the number that I'm reading there is actually 49. So that means the total value of days we have below that is going to be 49. Now, I'm interested for those that are more than this. Remember, our last value is going to be at 60. In fact, I went a bit more because I went all the way beyond that. The last point here on our graph, check where the graph ends. The graph ends at a y value of 60. So I want to know how many days are here in this group, because I'm actually interested in those that are more than because if you go back to the x-axis, from 65, you'll see that if you go to the right of 65, then it means you're getting more messages on the right-hand side. Those messages are more than 65. If you're going left, those are messages that are less than 65. So we are interested in the messages over the number of days over which we had 65 or more messages. So that means if you go back to the graph, you read the corresponding y value, you're just interested if I'm moving from 49 and I'm going to 60, what is the difference between 60 and 49? I'm getting an answer of exactly 11, so that means we've got 11 people in total. I mean, not 11 people, but 11 days. So the answer to this question is obviously going to be 11 days. So we got 65 or more messages over 11 days. So that's what the cumulative frequency can do for you if you really want to read stuff from it. An awesome question to get us started. We're coming back with a whole lot of more awesome content. Don't go anywhere. We'll be right back.
No one ever asks why we do the weird things we do. Like, why once is never enough. Or doing 2 trips is just one too many. Why do we, before we use these, or say 5 when we mean 20? Why do we have second thoughts? And think that lift buttons make them go faster? Why don't we walk there? Cross our fingers, touch wood, and struggle to hide our true feelings. At Liberty, we want to know all the weird and wonderful things that make us human, because human beings, being human, are what we make financial solutions for. Liberty, in it with you.
Did you know that at birth, baby kangaroos are only about 2 centimeters long? When the baby kangaroo is born, it emerges from its mother's womb no bigger than a jelly bean. It then instinctively begins to climb up its mother's body towards the pouch. Once safely inside, it will remain there for another 9 months.
Welcome back Tenfolders on a show that is proudly brought to you with lots of love by Liberty. A very special shout out always goes out to Liberty for affording us this awesome chance, guys, to share data handling ideas and stats to help you understand how do you work with grouped data, how do you draw the cumulative frequency curve, how do you draw a histogram, and how do you work with what we call bivariate data. Our next question is basically based on bivariate data. Like we say, if you're looking for the basics that will help you understand what is going on, because we are applying here, maybe you're interested in finding the basics that will help you get to here, just go to your App Store and download our Tenfold education app. It's an awesome app, packed with a lot of very useful resources. It will help you guys build yourself up as you're trying to understand the basics and the content in math and science and life sciences from grade 10, 11, all the way up to grade 12. If you're looking for resources, maybe you want more past papers, and then you're trying to prepare yourself by literally doing practical stuff, go to WhatsApp. We got you covered. On WhatsApp, Dex is waiting with a wealth of resources to try and share with you guys. Those are going to also help you. I promise you, if you're doing more practice, this is math. There is no way of learning math without looking at what you're doing here and trying to apply the ideas on your own practically. Just try and practice and see how far you can go when you're working with all of that. Perhaps you want to see, you feel like maybe you haven't seen enough and you want to see videos, just go to YouTube and then check. We've got the Mindset Learn channel, also packed with a wealth of resources. It's also there. Like those videos that we have in the Mindset Learn channel. Like them and share them with your friends. Let everybody know who's not watching that they're missing if they don't go to YouTube and check all these awesome videos that we have, including all the live streams of the shows that we're doing, and we actually share them with you. Thank you so much, guys, for sending the questions to us. Thank you very, very much. We're really grateful for all the questions that you sent to us. And the next question is based on what we call bivariate data. Now, before we even go into this, I want you to understand what is going on. The word bi immediately tells you that we're talking about two things here. So what we're trying to do is we're trying to compare the relationship between them. So you're trying to see, does one variable affect the other one? So you collect data between those two things to see, okay, when the first variable was this, the second one was this. When the first one was this value, the second one was this value. When the first one was this value, the second one was this one. So you check for the data over a number of times, then you try and find a lot of very important measures that give you a good indication of whether there's a relationship between these two things or not. For example, you could be looking at temperature. Think about temperature. Temperature versus sales of ice cream. Maybe you might want to know, does the temperature influence the number of ice creams that I'm going to sell? So that's basically the comparison that you're trying to work with. And our next question is literally based on something like that, where we want to see if one variable has an effect on the second one. If it does, by how much? Is it a positive relationship or is it a negative relationship? And then we use what we call the correlation coefficient to actually help you to see what is going on there. But then let's go and check it out. All right, so this question is an awesome question. It says to us here, the wind speed in kilometers per hour and temperature in degrees Celsius for a certain town were recorded at 16 hours for a period of 10 days. The information is shown in the table below, right? We can clearly see there in the first row, we've got wind speed in kilometers per hour. The examiner was nice. They're giving you the value X there. Usually, if nobody tells you that, we always put on the x-axis the independent variable, right? We always put the independent variable, and then on the y-axis, we always put the dependent variable. This is how we actually always compare the two, right? So according to the table, when the wind speed was 2 kilometers per hour, the temperature was 28 degrees Celsius. When the wind speed was 6, okay, the temperature was 26. And then when the wind speed was 15, the temperature was 22. So what we're trying to do here, we're trying to see, does the wind speed affect the temperature that you're going to get? Because you can clearly see, for example, when the wind speed was 20 kilometers per hour, the temperature was 22 degrees. And then when the wind speed was 25 kilometers per hour, the temperature was 16. So there might be a relationship between the wind speed and the temperature that you're going to get. So we're trying to check, does the temperature depend on the wind speed, right? And the measures that we're going to find here will help us and guide us in terms of finding these things. So I'm going to just pause here and say the following to do. If you get a question like this, let me just add something here again, because sometimes we put an extra column on top, and then you guys get confused by that. I don't want you to be confused. I want you to understand where is the data that is being compared, right? Very important. So you might find that sometimes they're saying here an extra column here that says days, right? And then they'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And some of you get confused because you don't know, I'm going to be inserting data in a calculator to compare two variables. Am I comparing days with wind? Or am I comparing days with temperature, or am I comparing wind with temperature? So you must just be careful. If you're reading the love letter, it tells you what are the two variables that we are comparing. And clearly, it says it's the wind speed versus the temperature. So the days are not part of it. They're just showing you over these days, this is the information that we managed to collect. So I don't know about you. Perhaps in your mind you're thinking, well, maybe the wind speed does influence the temperature. We don't know that. We're about to check if it does or it does not. Now, this is what I want to say to you. I want to say this to you. Before you even do anything, find what I call the 7 parameters of regression. You'll never hear this anywhere, only on Tenfold Live. Proudly brought to you by Liberty. All the time, nowhere else, only here. We haven't really asked you questions, but all the answers that you're going to retrieve come from the following things. You're going to find the following 7 parameters. I'm going to call them just 7 parameters. I call them the 7 parameters of regression, right? This is just something that I came up with. So you look for A, you look for B, you look for R, you look for X bar, you look for Y bar, okay? You look for the standard deviation, okay, let me draw the apple, of the X values, and the standard deviation of the Y values. So this is what you're looking for. The calculator will give you all this information, right? You can obviously manually work these things out, but that's not going to be a good idea to do. So let me call my calculator and ask you to actually assist me to figure out a couple of things. Remember, grade 12s, you go take your calculator, you push the mode button. After pushing the mode button, depending on the calculator that you're looking for, there will always be the stat option. So I'm looking for stats. So I'm going to select option 1 because in my calculator, it is option 1. Now, the range of options appear there. I'm interested in the one that has got A plus BX because we're predicting a linear relationship between the wind and the temperature. Yeah, you are in grade 12, so most of the questions that you're going to work with here are always going to follow a linear kind of like relationship, right? Okay, because we are interested in finding the equation here. We are interested in finding the equation, and that equation of the least squares. The equation of the least squares regression line is going to be the equation of the form y equals A plus bx. This is the equation that we're actually interested in. Where the a and the b will obviously come from my 7 parameters, okay? Those two values, the a and the b, will help you get the equation of y is a plus bx. Let me just remove that and write the actual number so that we can all see how do you actually answer these questions. Okay, so I said select the mode button and then go for stats. When you're there, look for option 1. We're looking for the linear one, a plus bx. It is option 1 in my calculator. Now you'll see that the calculator gives you an x column and a y column as well as the frequency column. Don't mind that frequency column. It's going to give you ones there. That just says this relationship occurs only once. So what are our x values? Let's start by inserting all the x values first. The first one is 2. So you insert 2 and then you press equal to. And then the next x value is going to be 6. So I'm going to say 6 equal to. The third one is 15. I'm going to say 15 equal to, and the next one is 20. Remember, we are studying the concept here, not the actual numbers that you see here. The concept is what we're studying, the ideas. You insert 25, and then you press equal to. You insert 17, you press equal to. You insert 11, and then you press equal to. The next number is going to be 24. You're going to press equal to, and the next one is going to be 13. You press equal to, and the last one here is 22, the 10th one. Is 22, and then I'm just going to press equal to. Now, if you press the arrows at the top, the one to the right, it moves you to the right. Then you just go up, 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 back to the first value here to try and write the number that corresponds to 2. According to the information that we have here, if you look on the table, 2 needs to match with 28. The temperature for wind speed of 2 was 28, so I'm inserting 22 to match with that. Equal to, it will replace the 0 that we had there. The second one is 6. 6 matches with what? 6 matches with 26. There's my 26 there, equal to the next one is 15 and 22. So 15 and 22, okay, I'm happy with that. Then 20 and another 22, very interesting. Okay, 15 and 22, 20 and 22. Okay, that's pretty cool. And then it says here 25 and 16. 25 and 16 is an opportunity for you to check if your X values are correct and you didn't make a mistake. Okay, then 17 and 20, there's 17. We're just going to insert 20 here. You press equal to, then you move down. I'm missing more numbers here. What is missing? After 17 and 20, I've got 11. Okay, no, we have 11. Okay, backspace, backspace. 11 must match 24, so I need 24 here, enter. You can always go back and edit these numbers if you want, guys. It's not a train smash. Okay, the next one is 24. It must match 19. There's 19. And then the next one is 13 and 26. Okay, 13 and 26, backspace, backspace. I'm just supposed to just insert 26 here. And the last one is 22 and 19. Okay, that's 22. I just need 19 here. Okay, then I just gave my calculator all the information that we got from the table, right? Put all the information in the calculator and then proceed to retrieve the 7 parameters. I call them the 7 parameters of regression. You are going to get them under stats, okay? So what you do is obviously have to clear the screen first. Don't mind the frequency values. Those frequency ones that you see there just mean that the relationship between 22 and 13 and 19 occurs once. The relationship between 13 and 26, that collection was done once. We don't have a lot of them, right? Very important. So I'm going to push the AC button. I have just cleared the screen. I need information now. So I'm going to go to stats. In this calculator, stats is on the button 8, but it appears in green. So that means I must press alpha first. So alpha, and then you press the button 8. A whole lot of things okay. So the statistics values, there's the regression values. I want you to go to that one that says regression. We are interested in that one. So you go for option 1, the regression. Press 1 and voila, a whole lot of things come up. So your A value comes up as 29.35 to 2 decimal places. Okay, let's go 29.35. There's 29.35 to 2 decimal places. Your B value, collect all of them, grade 12s, all of them. Negative 0.46. Okay, negative 0.46. If you do this, you'll never touch your calculator 8,000 times. You just touch it once, and then everything else will work out fine. There's an R value. That's what we call the correlation coefficient. Negative 0.93. Negative 0.93. Here's a secret. The B value always has the same sign as the R value. The correlation coefficient and the gradient of your graph always have the same sign. Okay? And if you try and press the down button, it gives you R squared. We're not interested in that. All right, now I need the X bar, Y bar, and the standard deviations. They are under something else. So go back to stats, clear your screen, go press the alpha button, and then push option 8 because you're interested in stats. And then you're going to press 0, and then you'll see there. The N value tells you how many numbers you inserted. It's 10. The mean of the axis is 15.5. So there's my 15.5. You need all of them, grade 12s. Okay? And then the mean, the standard deviation of the axis is 7.65. Okay, 7.65. All right, then you go to the bottom there. If you move further down, it will give you a whole lot of things about what's the minimum X value, what is the maximum X value. It gives you a whole lot of things about the axis. I'm now interested in Y's. I want the mean of the Y's. Y bar, 22.2. So there's 22.2. And then after that, I'm now interested in the standard deviation of the Y's. It's 3.79. Okay, there's 3.79. So you collect all these things. Be careful that the other ones, you get them under the regression option, and the other ones, you get them under stats or VAR option if you're using a different calculator. Right, so that's basically what I'm ending up with here. I'm happy with those values. I can now hide my calculator and start answering the questions. So someone is asking, why do I need all these things? You'll see something very interesting. The first two, they'll always work for the equation. They'll help you figure out what the equation of this is going to be. And that's what the first question 1.2.1 is asking us. They're asking us to find the equation of the least squares regression line for the starter. So that means that our equation, y, will be a, what's my a value? 29.35. And then there's a plus b there. My b is a negative. So I'm going to just say 0 minus 0.46 with an x here. And that, beautiful people, will be the equation of the least squares regression line, right? When will you need R? You'll need R if anybody asks you for the correlation coefficient. Let's see what they're asking you. Okay. Now they're asking, okay, yeah, let me just finish off with those 7 parameters. So the R value, you only give us R when we ask you for the correlation coefficient. That's where R will work. And then the X bar and the Y bar, they work for what we call the mean point. It's the mean point, right? That's what you're using for the drawing. When you draw the line of best fit, okay, grade 12, so when you draw the line of best fit, the X bar on the x-axis and the y bar on the y-axis, that point where those two meet is where the line of best fit needs to pass. Perhaps it's going to be an increasing line or a decreasing line. The one I'm looking at looks like it's going to be a decreasing line. So you'll get a line that is decreasing. That line must pass through that mean point. That is why you need to have the x bar and the y bar. Those two values are where your line of best fit needs to pass. Your least squares regression line does not have an option. It must pass through where those things meet. And then the standard deviation of the x's as well as the standard deviation of the y's, well, that is basically what you're just going to work with if you are interested, obviously, in finding the standard deviation. If anybody asks you for that, you just arm yourself with all the possible things that you can get. Why? Well, because the calculator already has them. Why should you wait? Don't wait. Find all of them, write them down. If they ask for them, just give them to the examiners. Okay, so the second question says predict the temperature at 4 or at 1600 hours if on a certain day if the wind speed was 9 kilometers per hour. So now remember the wind speed represents x value. So this is always your x value, right? We are interested in finding what y is going to be. Now obviously you can just call your equation and use it. Okay, let's call the equation and ask what the temperature is going to be. So we're going to ask for the temperature. We're going to put that equation 29.35 minus 0.46 multiplied by x. What is your x? Your x value, according to this, is they want you to tell them when the temperature was 9, when the wind speed was 9 kilometers per hour, what was the temperature? So therefore, the temperature equals, then you obviously go to call the calculator. You can clear the screen here. And then you obviously want to find what the answer is going to be here. So I want to know what is 29.35 minus 0.46, okay, times 9, close bracket there. And then I'm getting an answer of 23.59. So 23.59 degrees Celsius. You can round it off to 24 degrees Celsius. Okay, in order to get the answer that you're looking for. Right, so let's see what happened there. That's 29.35 minus 0.64, but 0.46. Okay, let's just fix that quickly. It's not, yes, backspace. You have to be careful and make sure that you're not swapping these values, guys. It's possible, particularly if you're writing under exam pressure, you might make these kinds of mistakes. So it's 25.21, that's what we're looking for, 25.21, not this. So let's just write that as 25.21, yes, 25.21 degrees. So that's 25.21 degrees Celsius, which is obviously approximately 25 degrees Celsius. Okay, this is pretty cool. If you leave it to 2 decimal places, that's the answer we're looking for, because we always ask you to round off your answers to 2 decimal places. Okay, now they're asking us to interpret the value of B in the context of the data. So your B value is negative. And if B value is negative, like I said, just like the correlation coefficient, which is negative 0.92, it is negative. It tells you that there is a negative trend here, okay? There is a negative trend. Graphically, if you had to draw this, how would it look if you had to draw it graphically, right? You would get a graph that is decreasing, okay? You'll get a graph that is decreasing because the gradient value is negative, okay? So what you would need is, if they were asking you to draw it, like I said, you'll have an x bar value and you'll have a y bar value, okay? Where they meet, that's where your line needs to pass. And then you'll have something that goes down. Why is it going down? Our line has got a negative gradient. So in the context of what is going on, if they're asking you to interpret the value of B in the context of the data, then you can say that there is a negative trend here, okay? That implies that as the speed increases, what is happening to the temperature? The temperature decreases. That's what is going on. Obviously, we've got temperature on the y-axis, and we've got the speed, the wind speed on the x-axis. So you can see as the speed becomes more and 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 more to the right, the temperature is falling and falling and becoming smaller and smaller and smaller. That is what the meaning of that answer is going to be. All right, thank you very much, guys, for sending through that question. We're going to come with our last question of the show. Don't go anywhere. We'll be right back.
Did you know that Antarctica holds as much water in its ice as the entire Atlantic Ocean? The Antarctic ice sheet covers 98% of the Antarctic continent and is the largest mass of ice on Earth. It's so big, it is estimated to contain about 61% of all the fresh water on Earth, which is roughly equivalent to all the water in the Atlantic Ocean.
Want to catch up on some of your studies? Join Mindset for late night studies. Monday is mathematics, Tuesday is physical sciences, with life sciences on Wednesday and accounting on Thursday. Friday is English, maths literacy on Saturday, and Sunday is a good day to catch up on geography. Every day from 9 p.m. till midnight, and again from midnight till 6 a.m. Late night studies, only on Mindset.
Welcome back, Tenfolders, to Tenfold Live, a show that is proudly brought to you by Liberty on today's program. We're just looking at data engine, guys. We're looking at stats. We just looked at a question that was talking about Bivariate Data. Remember, like we always encourage you, if you're looking for the basics, go to your app store. We've got them covered if you look for the Tenfold Education app. So now some app packed with a lot of resources. It will help you to stream the show live. In addition to that, you can obviously send us questions if you want us to help you. We are here to assist you guys. Like I always say, maybe you want past papers, you want resources to use at home. Dex has all of them. Where is Dex found? On WhatsApp. Just send a message, a greeting to the WhatsApp number you see on your screen now. Dex will load you or hook you up with a whole lot of very interesting resources that you can use to arm yourself as you're preparing for the upcoming exams. In addition to that, perhaps you need more stats questions that are done in a video format. Go to YouTube and look for our Mindset Learn channel. It's an awesome channel. Like those videos, share with your friends as well. Show some love there, guys. We love you Tenfold. That's why we bring you all these resources that we're sharing with you. So use them and also share with the others as well. And like them as well, guys. Thank you very much for being a part of this program. Like I said, we're doing data handling, and we're going to go to our last question, which is based on what we call a cumulative frequency curve that is sketched. So like I said, when we do these questions, we always try and select a question that speaks to a whole lot of other questions that you might have sent to us, right? So when we go through them, we always try and encourage you to see what we are doing. The stuff we are handling here covers all the questions that you might have on that particular concept. So let's go and see what is going on. How do you work with the question if they draw the cumulative frequency curve for you? All right, so this is question 1. It reads as follows. It says the amount of money in rent that learners sent while visiting a tuck shop at school. Or I think they want to see that the learners spent. Okay, let's read that again. I think it's supposed to say spent. Okay, the amount of money in rent that learners spent while visiting a tuck shop at school on a specific day was recorded. The data is represented in the ogive below. Okay, there's an ogive, aka cumulative frequency curve. On the x-axis, we have money and the classes The classes are here. This is where the data is, guys, the classes. So if you had to reproduce a table from this, you must know that the data comes from the x-axis and the cumulative frequency is obviously on the y-axis. The first question says, okay, they're saying an incomplete frequency table is also given for the data, which is pretty cool. You'll see that for the class between 10 and 20, we don't know what the value is of the frequency. Between 20 and 30, we don't know, we have 13, and then we've got 20, there's B, and then there's 4. 1.1. How many learners visited the tuck shop on that given day? Now look at this, grade 12, very important. When we're doing this information, we start with a certain number of kids, right? So you start with, for example, let's just say you start on a very small number like 5 kids. That's the frequency that you have maybe for the first amount. For those that spend between 10 and 20 rands, let's just assume that we had 5 of them. Now, if you move to the next range of, okay, between 10 and 20, I had 5 kids. Now, what I'm looking for those that spend between 20 and 30 rands, if I get 3 more kids, that means I'm adding them on top of the 5. I'm now sitting with 8 kids in total. So what you need to pay attention to is the frequency values keep adding and adding and adding new members. The kids that spend money between 10 rands and 20 rands are 5. Those that spend money between 20 rands and 30 rands are 3. Those that spend between 30 and 40 is 1 kid. So I keep adding. Now I'm sitting with 9 kids in total, right? Very important. By the end of these additions, the final value of the cumulative frequency will tell me how many kids did I account for in total. From the first group, as I keep adding and keep adding and keep adding until I get to the end, the final value of the cumulative frequency will give me the total number of the kids that are in that particular survey. So let's check here on our graph. What is the highest value on the cumulative frequency curve that you have? You can obviously read it from the coordinates that are given there. We have x and y. Remember, x is money, okay? And then y is the cumulative frequency. So we're getting a cumulative frequency of 65. That tells me that in total, we have 65 kids in total that we were looking at when we were checking this particular information. So how many learners visited the tuck shop? 65 learners. All right, let's go to the next question quickly. Now they're asking us to write down the modal class of this data. What stands out for me is the word modal, synonymous to mode. I think we all know that the mode is the most frequent value, right? The one that occurs the most. So now in class context, the modal class will be the class with most entries. The one that has got most learners in it, that's the one that you're looking for, right? So if you go back to the table, according to what we have, we've got 13 kids here, we've got 20 kids here, and we've got 4 kids there. But we can't say the modal class is the one that has got 20 kids in total, because we don't know what A is and we don't know what B is. Those could probably be the ones that have the biggest value. Now what do? We go to the graph and then we ask it. We ask it for the frequency. Right, why? Remember what I said. You start with a certain number of frequency values. When you add a new group, there's a jump because of the latest frequency value you've added. When you add the next group, there's a jump as you keep working out the cumulative frequency. So the one that will have the biggest frequency is the class that will have the biggest jump from one dot to the next dot, because you're moving from nothing, you keep adding kids, 2 kids, 3 kids, maybe you add 7 kids. Depending on how many kids you're adding, this thing moves from one dot to the next and it moves vertically up. So you're gonna check for the class that has got the biggest jump moving up. Okay, let's look for it. So we're gonna look at it from the graph. The first one jumped from 0. The first one jumped from 0 to 12. The next one jumped from 12 to 25. If you look at them, it literally looks like the one that is the biggest jump is from this one here with a frequency of 25 to that one there with a cumulative frequency of 45. And the difference between 45 and 25 is exactly 20. So I'm not taking it because it's because of the fact that you can clearly see that the change in Y values here is equal to 20 moves up. It's the one that looks like it has the biggest jump. And I think that will be the class with the biggest entries. On that note, if they ask you to find the A value, that will be the frequency as you're jumping from the smallest dot there, or the first dot to the second dot. You jumped from 0 to 12. That means you added a frequency of 12 values. When you jump from that dot to the next dot, you moved from 12 to 25, you added 13 values in total. The next dot to the next dot, you added 20 learners. From 45 to 61, you obviously added, I think you have to find out what's the difference between 61 and 45, and it gives you 16. So you added 16 values here in total. And then if you jump from 61 to 65, clearly from this dot here to the last dot, you jumped by 4 units. That's why the frequency values that you see on the table are corresponding to those jumps moving vertically upwards, because those are literally your frequencies. In fact, as a matter of fact, I can claim here the A value is going to be 12. I can claim that the B value is going to be 16. And clearly we can see that one of the biggest frequency value is the class between 30 and 40, and that is going to be our modal class. So between 30 and 40, that is going to be the modal class. So what are they looking for? They're looking for this, and that's going to be the answer for this question. Right. So now the last question is asking us to determine the value of A and B in the frequency table. The value of A and B in the frequency table, already found them. Like I said, it's the jumps from dot to dot. A value is 12, so my A is going to be 12, and the B value is going to be 16. Because the B value is the class when you were jumping from 40 to 50. By how many moves did you move on the y-axis? From this dot of 40, going to the dot of 50, moving up. I think we moved from 40 to 50. The move is here. I'm going to put it in green. It's this move here, right? And that move here, the change in y is actually equal to 16. That is why we are saying our B value is going to actually be equal to 16. Last question says, use the cumulative frequency curve to estimate the number of learners who spend at least 45 rands on the day the data was recorded. Okay, so we're obviously going to need the cumulative frequency curve in order to do this estimate. We've done a question like this before. We don't have the we do have the cumulative frequency curve. So what do? You go look for 45 on the x-axis. Find 45 on the x-axis. Let's put it in blue. Where's 45 on the x-axis? It's going to be somewhere here. Let's find that 45. It's going to be 2, 4, 6, 8, 10. So 45 is here. You go to the graph. When you get to the graph, you try and read what is the corresponding y value. And I'm getting 52, 54, 54. Okay, that's 54. So that means the total number, the number of kids that spend 45 rand on a day that was recorded at the tuck shop. Total number of learners who spend at least 45 rand. That's going to be 45. That means when you say at least, it's 45 or more. So you need 65. You need these kids here, which is obviously going to be 65 minus 45. And the answer that we're getting is going to be 54, actually, not that. 60. I think we have to subtract 54. And the answer is going to be 11 kids. The answer is going to be 11 kids. Thank you very much, guys, for being with us on Tenfold Live, a show that is proudly brought to you by Liberty. I hope we helped you. We're looking forward to helping you more. Keep watching the program. Until we meet again next time from me, a big shout out to Liberty, a big shout out to the production team. We'll meet again next time. Bye-bye.
What's up, peeps? Welcome to Moby School. We are here to make sure that you get all the marks that you deserve on the go. We're here every Mondays to Fridays from 2 to 3 p.m. only on Mindset Learn TV. Now, this is a whole hour worth of revision just for you. And I hope that you've got your notepads and your pens ready and that you and your study group are game for today's revision.